All right, so starting with example 1, we are going to identify the domain and the range in each graph. Okay, the domain and the range, and then we're going to write it in stat builder notation. And like I said, it's completely okay if you've never heard of stat builder notation before. I'm going to go over that with you, and then it is something that you're going to use in all your future math courses. One thing you'll notice is I like to highlight what I'm trying to find, especially because some of the directions get complex. So I want to identify the domain and range, and then there are certain ways you have to write things. So this has to be in what's called stat builder notation. Okay? Whenever you're doing the domain and range from a graph, it's best to look at the x values. So the x is the horizontal axis. So when I say horizontal, we know that means left to right, right to left, side to side, perfect. Okay, so if there is an arrow, what that means is it continues forever and ever and ever. Okay, do you guys know in math what we call it if it goes on forever?
Infinite.
Yeah, infinite or infinity. So if it's going to the right, we call it positive infinity. And then here you can see this is going to continue going to the left. We call that negative infinity. Okay, so if something is going from negative infinity to infinity, it encompasses everything. We say, sometimes we'll say that there's no restrictions. And spoiler alert, a lot of our graphs are going to have no restrictions for the x value. Many of them will. And if there are no restrictions, we're going to write this on the side, and then I'm going to show you how to write it in stat builder notation. Okay, so do you guys know what this means? What I just wrote here. You know what this symbol is? Yeah, all our numbers. Good. Okay, so the real number symbol is a capital R with a line through it. Okay, and real numbers is any number you can think of. Probably like, why would we even call it that? Well, there are imaginary numbers, but we'll learn about those this year. Okay, and then the way that we write this in stat builder notation, let me know if you remember this from your earlier days. Do you guys remember this as a set? And then sometimes you list like different elements in it. So stat builder notation is going to have x and then that line. Okay? That line means such that. So for your domain, you can say x such that. And just do your best with the fancy brackets. If you're struggling with the fancy brackets, you can always think of it like a backwards E. Or when you guys were kids, did you ever draw birds in the sky like this? Because I did. And you could just turn them on the side, that would be fine. Okay? Alright, so this is all real numbers of x such that x is an element of the real number set. Okay, so x such that x is an element of the real number set.
What's that element?
So the element is just something that belongs in the set. So a lot of times the element is a number. And it is like a curved E is how you'll see it. Okay? And then the R is the real numbers. Okay? And remember, this means such that. Again, we'll practice that.
Wait, so what's the element like? So why is the element next to x?
It's saying that all of the x values are in the real number set. So all of the x's are going to be all the numbers here. Really, it's any number you can think of. So a lot of times we think of the whole numbers, but it's also anything in between. And the range, again, now we're looking at the y, which is vertical, up and down, right? Well, if this continues up forever, we're at infinity. If it continues down forever, we're at negative infinity. So we have another situation where it's all real numbers, but instead of using x, because it's the range, we're going to use what? Y. So it's y such that, and again, this means that any output is going to be a real number. Any output that you have, any y value that you have is going to be a real number. Alright, now we're going to do B together as well. So the first thing we do when we're looking for the domain is look side to side, okay? On the left side, is this going to keep going forever as x keeps getting smaller? Is this going to keep going up and going towards the left? Yeah, same thing on this side. So guess what our domain is? All real numbers. Guess what? If you're not sure what it is, please just guess all real numbers, because 99% of the time in this chapter it will be real numbers. Okay, of course there are some exceptions, and I will go over an exception with you today as well.
Wait, so if you don't know an answer to the question, you just put all real numbers?
For the domain, yeah, I would say if you're not sure, that's your best guess. So you guys heard me say for this one too, the reason is there's no restrictions on x. The only time there will be a restriction on x is if there's a special type of function, like a vertical line, or something that gives you an error. Okay, but for these graphs that we're doing here, that domain is all the numbers. Now, let's look at the range. So the range is the up and the down, okay? What is the highest point this graph is going to go to? Infinity. Okay, great. What's the lowest?
-2.
Perfect. Do you guys, this is kind of ambitious, but do you guys know how to write that? Okay, that's okay. Okay, so would you guys agree that all the points on the graph are above -2? Okay, so all the y's are above -2. So we're going to use an inequality. So y is good, greater than or equal to -2. Great work. Alright, and then I'm going to have you do C with your row, okay? So again, I want you to do the domain and the range, and it's going to be in stat builder notation. Oh, the E just means it's the element of that set. So whatever value you have is going to be the element of the real number set. Still the equal means it's a real number. So it's kind of like it is. The x is a real number. Okay, so you guys feeling confident? Yeah.
Like, so when you put the line,
Yes.
why do you put why do you do that?
So that's just the notation. So it's kind of like, why do we put the line through the R for the real numbers? That's just the notation. I don't know where it comes from, I just know that's what they did there. Okay, so for this it is x is, what is it? All the numbers? How do we say it? X is an element of the real number set. So a couple of people have asked me about the E, the element. You can just think of it as it's included in this number. Okay, so X is a real number. So think of it as it is. X is a real number. Okay, what about the range? Is that all real numbers or something else? Alright. Greater than or equal to? Good. Oops, what did I do wrong? Yes. Okay, so y is greater than or equal to 1. All the points are above 1. Okay, so they are all above 1 here. Sometimes I just do this or I'll write it. Okay, so the y is above 1. Great. Alright, now I think you're really going to like the domain and range for problems like this. And I'll talk about the elements in this as well. So we have a table. It shows the number of raffle tickets that are sold for the first 6 hours of a fair. we have to define the domain and range. Okay, we have to define the domain and range of the function. Okay, so when you are looking at a table, the first row, or in some cases the first column, depending on how it's set up, is going to be the set of input values, which we know correlates to the domain. Whereas the bottom row, or the second column, corresponds to the output, which is the range. Now, when you have actual numbers like this, and it's not on a graph, when you are doing the domain and range, all you have to do is list the numbers, and if a number occurs more than once, you only have to put it once. For example, for the domain, all of my input values here are 1, 2, 3, 4, 5, 6. So I'm just going to list them like this. 1, 2, 3, 4, 5, 6. Each element is separated by a comma. Okay? So the set of domains, like 1 is an element, 2 is an element. Nothing related to the science element. It just means it's included in the set. Okay, so now we're going to do the range. Are there any repeats here? No. If there were, again, you just have to write it once. And if you can put it in numerical order, that is preferable. Alright, and that's it. That's all you have to do for the domain and range there. So if they are finite numbers, okay, then you can just list them. Alright. Example 3. Determine whether each function is 1-to-1. This is where we're going to use the horizontal line test. I'm also going to warn you that there are some things in this book that we have taken out. And so what I've done for your notes is I've lined those up with your homework problems. So for example 3 in your homework, all you have to do is follow these directions. I think in your book it asks, is it 1-to-1, onto, or neither? If we did not do it in the notes, you do not have to answer that. Okay, and I'll go over that again because I'm going to give you some time to do that today. Alright, so let's use the horizontal line test. So pick one of your pens or your pencil. And all we have to do is see if it crosses it more than once. So does this one cross it more than once? Yeah. So I'm a visual person, so I like to draw. Okay, it hits it twice. So then I know it's not 1-to-1. The second one can be kind of tricky because it does kind of look like this part is flat. But it's just because these are increasing very, very small numbers. So this one, there is no place that hits more than once. So we would say, yes, it is 1-to-1. Okay, and I'm going to show you different ways you can write out 1-to-1. So if you would like to write out the full thing, you go. If you would like to write it out like this, that is also okay. And then for the last one, is that 1-to-1 or not 1-to-1? Nope. In fact, you have an infinite amount of points because if you use the horizontal line test, it hits it all. Okay, so this is not 1-to-1. So you can choose which one you like the best, okay? Or which formation. Alright, you guys are doing great so far. We're only going to do the one more example today, and then I'm going to give you some time to do some practice. Okay, so we're going to talk about functions that are continuous and discrete. So if a function is continuous, it means that the line or the curve is unbroken. These are very common graphs that you have seen before, like in Algebra 1. Can you guys tell me what type of function this is? Is what? Yes, sorry, can you tell me the name of the function family? It is continuous. Linear function, good. What about something like this?
Lateral.
You're close. Quadratic, yep. And then do you guys know what the shape is? Yeah, good. All right, so those are two continuous functions, okay? If it is discrete, it is discontinuous, and the points also are not connected. Okay, so the points are not connected. Okay, so that might look like something called a scatter plot. It is where you just have the points only. Okay, so it could look something like that. That would be discrete. Okay, so for example 4, examine the graph, determine if it's discrete, continuous, or neither. And then we're going to state the domain and range of each function. Okay, so we're going to do the first part for each of them. Okay, so is this discrete, continuous, or neither, do you think? Continuous. Continuous. Okay, what about the second one? Discrete. I know you guys are very intelligent, so you could probably even guess the third one even if you weren't sure. Yes. So if it is neither discrete nor continuous, this would just be a discontinuous function. So the discrete will never have a connection. Okay, we can see we have points here, but they are connected, but there is a break in them. Okay, so it's not continuous because of this break, but it's also not discrete because you do have some connections. Okay? Alright, now we're going to do the domain and the range. Alright, so again, with the domain and the range, we want to try to find the lowest x value and the highest x value. What's the lowest x value for this? 3. What's the highest one? 3. 3 is the only value, right? That's the only place where it is. So your domain is only 3. Sometimes your book puts an equal sign instead of a colon. I don't care which one you do. I'm just going to expose you to both, and then you pick your favorite. So you can put the equals or you can put a colon. Okay, so the only x value that we have is 3. That's why it's only 3. Okay, there are arrows on it, but they're not, the arrows are not going side to side, right? Where are they going? Up and down. So that's going to be the y. So y goes all the way up to where? Infinity, and it goes down to negative infinity. Okay, so then when we're writing the range, it's y such that y is an element of the real number set. Okay, and then the discrete, if it's discrete, all you have to do is look at the x values of each point. Now this is nice, they actually wrote them out for you. You might have to find it yourself, but your x values are 2, 4, and 3, so let's just put those in the proper order. 2, 3, 4. Okay, and then we're going to do the range, which is very similar. So now we're just going to look at the y's. 3, 1, negative 1. So if I put that in order, I'm going to start with negative 1, then 1, then 3. Okay, so if it's continuous, we're going to write it like this. Discrete, you have the numbers. Now the neither, we're going to learn interval notation. Interval notation, we're going to use brackets. We're going to connect them with a symbol, and you're going to have to help me on whether it looks familiar or not. So intervals connect. We call these intervals. There's 2 different intervals here. They connect with a U. It stands for union. Okay, so this symbol looks like this. Is that something that seems familiar or not really? Oh, good. Okay, so you may have seen it last year like this. A union B, like if you had two different sets. Yeah, well, did you guys do it with like Venn diagrams sometimes? Okay. And then this is like the intersection, so this is just the U. Okay, and then we're gonna use brackets for most of them. So brackets are like this. And then sometimes you have parentheses, and that's only if you have negative infinity or infinity. Okay, so parentheses are only for negative infinity and infinity. Okay, so because there are intervals, we have to look at them individually. So let's start with the x's. So let's start left to right. Okay, so if I'm starting from the very left, I'm here. Where is that on the x?
1.
No.
-4.
Yeah, -4. And then it goes here. So on the x's, that would be 0. Okay? So the way that I'm going to write the first part of the domain is -4, so with a bracket, to 0. This is an interval. Again, I know that's new, so it may feel kind of strange so far. Okay, and then we're going to connect it to this other interval. Okay? So this other interval, where does that start on the x? 1. I'm putting a dash, but I'm also putting 1. And then it's going to go on to what? To infinity, yeah, because the arrow means it's going to keep going. And that's where you use, sometimes you'll call it, bless you, a soft bracket or a parenthesis. Okay, good. Now let's try the range.
So would you put the infinity like within the brackets, or just you use a bracket on one side and a parenthesis on the other?
Yeah, so whenever there's a number, you'll use the bracket, and then the infinity will always be capped off with the parenthesis, no matter which side it's on. Okay, now, remember, for the range, that is the up and down part. That's the lowest to the highest. So when you're thinking of the range, I have two intervals that I'm going to look at, okay, but which one is going the lowest? And where is it going? What value? Infinity. But see how it's this one? This one is the lower one of the two intervals. So yeah, this arrow is going to go on the y's to negative infinity. Okay, and I'm going to put it over here just so you can see it a little better. Now, it's going to go from negative infinity to, what's this value on the y? Okay. Alright, so we can write that as an interval. Negative infinity to -3. And then do you guys want to try the last one? So you're just going to tell me what this interval is here. Again, it's an up and down. Okay, so this hits here at -2. And I really do, I like to draw on these, like that helps. Like, okay, I'm going from here to here, right? So this hits where on your y? At 2. So -2, comma 2, that's what you got. Okay, so I'm going to show you your calendar. I moved some things around for the better. So we have a few things coming up, and